So with each and every project, you are trying to develop a particular skill set. You are trying to encourage, you are trying to motivate individuals in order to take up science, in order to solve problems.
Greetings, Chalusment. This is your host, Witumela Mamadi Mamarope, and I am joined here on another session of Passion or Option. I'm here with Cuthbert Kibungu. He is originally from Uganda. He carries a master's degree in microbiology from University of Fort Hare in the Alice campus in the Eastern Cape. So, Cuthbert, welcome to the show, and thank you for joining me.
Hi, Butumelo. Thank you very much for having me.
Yeah, thank you. On the show, Cuthbert, we like to take it back to the roots, and I would like you to tell us who you are, where you come from, just paint a picture of your childhood so that, when the youngsters see this, they can see that you don't have to come from a glossy place. You can come from nowhere and get somewhere.
All right, thank you. So I am originally from Uganda, which is located in the East African geographical region on the African continent. I come from a very poor area in Masaka district, and that is where my parents are from. So the reason why we came to South Africa, obviously, was to seek greener pastures and to try and find better opportunities for the children, which is myself and 3 other siblings. So we then came to South Africa around 1996, and my dad, that's where he had got a first job, which was in Lesotho prior to 1996, before us joining him in South Africa in 1996 exactly. So we grew up in a rural town known as Fort Beaufort, which is near Alice, where the University of Fort Hare is located. So we've been in Fort Beaufort for about 23 odd years, and it wasn't really easy to say because we run a family business, which is an agricultural business. So us as the children had to be pretty much hands-on and involved in the business in order to make money available, which would be paying our school fees and also be able to look after the home, because my dad was the only person working at the time, and my mom was more of a support system to him. So in the beginning, it was not really easy growing up, because we had to work very hard and then at the same time focus on our studies, because academics were very much a priority for my parents. They never settled for low grades and all of that. So we were very much under pressure to perform, both academically as well as in the business, in order to ensure that our futures are bright.
Yeah, hey, you did work hard, I can tell.
Thank you.
So, when did you fall in love with science, and how did you get to know about it?
To be honest, when I had just finished high school, primary school rather, it was not really clear as to what I wanted to do post high school. But I remember we had a career exhibition event at high school. I think it was in the year 2010, when I was doing grade 10 at the time. And the main scope of it was, what would you like to be when you finish high school? And at the time, I wanted to be a medical doctor, because I felt that was more of the fashionable thing to do at the time, and being called doctor and that title and all of that.
Yeah.
But as the time went, I did present on being a medical doctor, but then I did some job shadowing at the nearby hospital, and I actually realized I'm scared of blood. So I was like, medicine is not for me. But then our life science teacher was a very incredible teacher, because she was teaching us beyond the curriculum of high school studies. So she basically opened our minds to different branches of science, And her being a biology teacher or life science teacher, she actually introduced us to the different sub-disciplines which fall under the life sciences. So I decided to go into a stream which was pretty much closer to medicine. And I felt that microbiology and biochemistry and zoology, botany, all of those are very much close. These are supportive disciplines. If one is to go further with those disciplines, you actually find that these are fields that provide solutions to existing problems within the medical field. So microbiology, in a nutshell, is the study of organisms that are of a minute or microscopic magnitude and are not visible to the naked eye. And we're all aware of the COVID pandemic, which is caused by a virus that's not, visible to the naked eye. So that is where the link or the love and passion came from, because these are types of sciences that provide solutions to problems which are found within the medical arena.
Wow, I must commend your teacher for brilliant work that she did there. Like,
indeed so.
yes, he did. And because you even touched on that, we need people like your teacher, people who want to share information. So you mentioned different fields of science there. Do you mind maybe going a little bit into explaining what each is, even if you don't go into details, like just paint a picture of what is botany? You did paint a picture of microbiology, but each one of those that you mentioned, just paint a picture of those.
Okay, so the main ones, I'll speak from a point of reference with subjects that I did in university.
Yes.
So botany is simply the study of plants. So it's the science involved around plants, and that can include sciences which are involving biotechnology, plant physiology, plant pathology, and so forth. So those are mainly the sciences that deal with plants, whether it's for crop production or for medical purposes. Botany would be the field. And then zoology is a field of study where science really revolves around animals, and there are a lot of animals. This could be marine animals such as sponges, such as squids, such as octopus. And then also it revolves around animals like lions, leopards, cheetahs, pigs, goats, and so forth. So zoology also is intertwined with other sub-disciplines, whereby you find that veterinary sciences is a good example, where you get animal pathology, you get animal biotechnology, for example, where insulin is made as a commercial product and it's obtained from pig insulin, whereby it is reproduced and commercialized in order to treat diabetes. Then other disciplines are entomology, which is simply the study of insects. Entomology is also broad because now there's a new discipline called medical or forensic entomology, where, believe it or not, crimes can be solved using insects. Then there's also a sub-discipline of that, which is referred to as medical entomology, whereby certain insects are used, or enzymes and compounds produced from certain insects are used as medical remedies. And then another type of sub-discipline which will exist are your geosciences, whereby they try to link the behavior of the ocean or the environment together with the abiotic and biotic factors that are revolved around that. So those are the main subspecialties. Another one, before I forget, is chemistry as well. So chemistry can be broken down into biochemistry as well as medical chemistry. So with chemistry, you get different types of chemistry, which is your physical, your inorganic, your analytical, and so forth. And these are also, once again, intertwined with the other disciplines which I've mentioned, because chemistry is important in zoology, chemistry is important in botany, chemistry is also important in microbiology.
Yeah.
So those are the main sub-disciplines that fall under the life sciences.
Very informative and very articulate. Thank you so much. Going forth, are you currently doing your PhD, or are you currently enrolled as a student?
Okay, so currently I am enrolled in a full-time capacity, also employed in a full-time capacity at Wits University as a researcher. Then the PhD is, I also enrolled for it starting from last year, which is 2019. So I'm currently in my second year. And I specialize in an area known as pharmaceutical chemistry with some twist of material science as well.
Oh, that's great. The reason why I asked is because I would like you to, I don't know which project you want to talk about, but maybe just tell us about one of your project masters or current, the PhD one. Just tell us about the scope of your research. Which problem are you guys trying to solve out there? And how exciting, make it exciting. I'm excited on the science part of things.
Okay. So I'll start with the masters. I'll be very brief with it. So I worked on a project with my masters, for my masters rather, in terms of discovering new antimicrobials. As you may know, that there's an increasing resistance to antibiotics from bacterial species, whether it's your methicillin-resistant Staph aureus or your multi-drug resistant tuberculosis, which causes TB. So we had to dive down about 20 meters below sea level in Port Elizabeth, which is in the Eastern Cape. And we collected small, funny creatures known as marine sponges, and we tried to isolate novel bioactive compounds from them. We were very successful on that regard because we managed to identify a number of bioactive compounds from the extracts, which actually inhibited and killed the test pathogens. So we dealt with pathogens like Candida albicans, we dealt with Aspergillus fumigatus, which causes ventilator-associated pneumonia. We dealt with Clostridium difficile as well, which is a bacterial pathogen that is causing a lot of trouble in clinics and hospitals, just like Pseudomonas aeruginosa. So that project tried to solve the issue of trying to find new drugs to treat bacterial and fungal infections. So the important aspect thereof is having broad spectrum properties and not just killing bacterial species, but fungal species as well. So that was a project which was very much successful, very much the first to report such findings in South Africa. And it very much also introduced a lot of knowledge into the scientific arena. And then for my PhD, it's quite broad, so I'll try to summarize it as much as possible. So we're trying to develop wound healing system in order to treat patients who might have come across electrical burns or burns caused by fire or burns caused by hot plates or whatever the situation is. But we're trying to find solutions to that by developing wound healing patches that accelerate the wound healing process and reduce it by almost 7 to 14 days. So we're looking to develop a system which is firstly biodegradable, biocompatible, environmentally friendly, and cheap to produce. I think that those are the important aspects. Developing a product using green chemistry, and then secondly, something that's very cheap to produce. Those are the main goals, and also the ultimate goal is to improve patient compliance. So what do we mean with that? You might have a cut or an injury, you go to Discam or Clicks, you buy a patch and you apply it onto your skin. The issue is not actually applying, the issue is actually removing. You find that there's a lot of pain involved, and maybe there's too much scarring also that is caused by this wound patch, or you find that the wound fluid is not absorbed by this bandage or gauze, or yes, with that regard. So we're trying to develop as what is referred to as a super absorbent wound healing matrix, which mimics what we call the extracellular matrix, which is basically your skin. So it's a very interesting project, very difficult to do, I must add. It's not really easy science. So we deal with what we specialize in, which is basically polymer science, which is a subdivision of material science. But a lot of pharmaceutical chemistry is involved, because we have to manipulate a number of functional groups in order to induce new properties onto the matrix, which are trying to improve. So that is basically the simplest way of explaining the project. It's a very interesting, very exciting, because the platform, once it's been developed, it can be manipulated into different ways. For example, incorporating drugs, antibiotics or antifungals in case the wound has an infection. Growth factors can also be into the wound matrix, which has been developed. So that means when you introduce growth factors, you are actually trying to accelerate the wound healing process. That is one. And then secondly, you are trying to improve the recovery of the damaged area. So we're looking at cell proliferation, cell migration. You're looking at reconstruction and redevelopment of the blood vessels that might have been damaged in the process, as well as the cells in terms of how they regenerate. So we're talking basically about tissue regeneration. So that is the science around our project, which we are doing.
Wow, really interesting, really interesting. I can imagine you trying to make like a synthetic skin, because that's what I'm picking from from the
Yes, that's
experiment.
correct.
Okay, having explained all this complex, not really that complex though, issues around your project and what you've been working in, what are your thoughts of the future of your work, your project, your workspace with the rise of the 4IR? So where do you see your line of work fitting within the space of digital transformation?
So this type of a project is, because for me, I believe science is continuous, firstly. Secondly, science is reproducible. And then thirdly, you need to bring about change with whatever project you are doing. They need to be change involved. So starting with the first aspect of it being continuous, I believe that it's a project that is not going to end anytime soon. Yes, the PhD will end, but I mean the science around it is going to be continuous. So people who are doing similar projects would be able to try and use different approaches to solve different problems. It might not necessarily be a problem pertaining to skin burns. It might be a problem maybe that pertains to spinal cord injury, head injuries, ocular delivery of medications or ocular drugs. It might be a project that pertains to bone engineering. So the platform is still constant, but the applicability can change. it's not really limited to application to wounds. It can be applied to various areas of study. So it is a project which can develop numerous number of novel technologies, because the main aim of developing this platform is to deliver drugs, to be able to produce a platform that's got sustained release. So if you've got anti-inflammatories, they are not released rapidly, but in a sustained and persistent manner. If you've got drugs incorporated to treat infections, maybe within the wound or within the eye or within the bone or wherever the injury might have occurred, the sustained release. And then for the aspect in terms of reproducibility, it means that whatever has been done in the lab can be taken to the market. So now we're talking about industry-based projects, and that, I believe, is where the fun begins, because it's a project which you get to see going from a small confined area, which is the laboratory of a university, to the industry, like for companies like Novartis and Aspen, and then to the shelves, which is a very, very, very rewarding aspect to see, because all our PhD projects that we are producing have the possibility and the potential to get patented, meaning that they will own rights, or rather the student together with the institution where the study is taking place have the opportunity to produce a commercialized project. And then the third aspect is change or transformation. So with each and every project, you are trying to develop a particular skill set. You are trying to encourage, you are trying to motivate individuals in order to take up science, in order to solve problems. And it's one thing to solve an existing problem, but it's also another thing to solve a problem which you know is going to bring about change. We get positive problems and negative problems, but I think the confinement of all research projects is to solve problems that are relative to a community. So for example, if you find in Soweto a certain section, there's always cases being reported of children suffering from burns, electrocution caused by electrocution, or a falling candle that ignites an informal settlement. You find that these children get admitted to hospital. They sit in hospitals for 6 months to a year with these injuries. But if we're able now to provide a solution from a research point of view, and then from a community engagement point of view, are also able to provide a solution by meeting those communities, we are able to use our research as a platform and as a tool to bring about change. So that is where I see my project going post PhD.
Wow, really, really interesting. I'm looking forward to buying those patches. Not that I want to be banned, but I'm looking forward to seeing them on the shelves. So I want us to go back to your teacher. I'm really touched by what she did for you. So reflecting back on how she, used to corner you guys down and tell you about these aspects of biology and all that, how do you think going forward the government or even the private sector can improve the way in which young people are being introduced to science? How do you think, what do you think, what more should be done to introduce those people to science?
I think so far government is trying their level best. I think with the platforms that exist, like the ESCOM Science Expo, the National Science Week, there's a event that usually takes place in Grahamstown at Rhodes University, which is also talking about, bringing high school learners and primary school learners to, understand and be aware of the crux of science, as well as trying to familiarize them with, the possible gateways that they have in terms of their future. But I believe it is more of a responsibility of the teachers at school more than anyone else, because the interaction of learners is much more higher with their teachers as compared to even their parents. You might find a child is living with their gogo or their tamkulu, as they are called, and they are not aware of science. You can't really blame the grandparents or the father for not knowing, because maybe they might have not had that opportunity. But I believe when children come into a classroom, they should be perceived as, the teacher's own child. What future would you want for your own child? Therefore, you would try your best as an educator to go beyond your job description and ensure that the students are very much aware of the opportunities that are out there. I feel the curriculum personally is not doing enough in terms of letting or bridging the gap between the opportunities out there in terms of science, as well as, the possible career guidance avenues that children need to be aware of, because you can't just wake up one day and say, I want to be a medical doctor. You need to know the implications. You need to know how you should prepare for that. You need to know the number of years of study. You need to know which subject or disciplines are entailed in that field of study. Are there core areas which you would love to venture into? Those are the type of things which need to be made aware to learners. So I think the curriculum needs to be re-evaluated in terms of, I don't know what they call it now, if it's still life orientation or it's life skills, but I think government needs to incorporate the curriculum. It needs to revise rather the curriculum so that learners are also able to learn about possible career avenues, not just in science. I think also in commerce, in computer, IT and all of those, because, not everyone might want to venture into science. But I think if we're relating to the topic at hand and we say science, teachers need to be very much aware that science is broad, identify or do a SWOT analysis of the class, and then know what are the strengths and the weaknesses of the learners, because some might be showing excellent potential in mathematics, but they're not aware of actuarial sciences or mathematical computer modeling and all of those things. So I think it falls under a responsibility that educators need to carry on their shoulders and lead the way. And then when learners get to university, they are very much aware of what is expected from them, as well as how much energy they need to put in if they want to make things work. Because a lot of my colleagues, when I was doing Maths 1 first year, were very much surprised that Maths is so difficult at university. Why didn't the high school teacher tell them they were getting distinctions? Now in university, they are getting 40% and all of that. Why were they not told? Then I said, well, sometimes it's a responsibility that falls on both sides. If you really want to do something, I believe you should have some stimulus of curiosity and find out what this thing I want to do involves, what is expected from me, and how do I best go about it. Earlier on, I mentioned that I wanted to study medicine. So in order for me to find out what medicine entails, I went and read the requirements of the universities, and then I further did some job shadowing for a month, only to find out that, no, this is not what I want to do. So imagine if I had started my first year, my parents are expecting a doctor at the end of 6 years, while I'm sitting with other ideas of deregistering and starting another course. So I think it's more of a responsibility of educators, but I think also learners need to play their part as well.
Yeah, you actually nailed it there. You nailed it. People should be curious and do research. Don't just say, I want to be this and that's it. And like you were saying, there was a point in my life when I thought I want to be biomedical scientist. I only realized that I don't want to be that when I job shadowed at a hospital. I was in a hospital for I think a month, and I was like, nope, I don't want this. So, so that's how it works. Okay. Thank you so much. Do you have any advice for an aspiring scientist, somebody who wants to do this?
Okay, so usually I don't have a consistent form of advice I give people. It differs, but I usually say to them that you need to first know or be able to tell the difference between doing what you love and loving what you do. Because if you do what you love, that comes with passion, that comes with desire, that comes with hunger. If you love what you do, you could love what you do, but you're not entirely happy with it. Because yes, this is something you're going to be waking up, going to do every day. It's a routine, but you don't have a sense of purpose. So I think be inquisitive firstly, have an element of curiosity about what you want to do. Go and do research upon it and try and find out what this entails. What are the expectations and what are the advantages of this process? And then lastly, try I always tell people that it's not bad to ask for advice from people who have been there, or friends or peers and so forth. But if you want something, you shouldn't let people's advices determine what you want to achieve, because sometimes you find it's positive advice, sometimes you find it's negative advice. People will always have something to say, but if someone is not really happy about the career path you want to take, they can advise you in a wrong fashion. So I say you need to be having that desire, that hunger, that fire, the passion, know what you want to do, stimulate a form of curiosity. Hard work is very important, more especially in the science field. You need to also be able to understand that things are not going to happen overnight. A lot of hard work needs to be put in. But most importantly, with all I've said, is that you need to enjoy. I think that is where science becomes exciting, because if you enjoy what you are doing, you will always have that passion, you always have that hunger, desire, because whatever you are doing will come naturally. It will come from deep within, and it's always important to be humble. That's the closing remark I will give. So no matter how you excel or how you go about achieving your goals, always be humble before others, and always be willing to learn. You never think you know everything, because
Yeah.
that's the dangerous thing as scientists always do. We think we know everything, but trust you me, we only know about 15 to 20% of what's really out there. So we need more people who have got that desire to learn, that desire also to export whatever knowledge and skills they have to others, and then also be a driving force for change. Always advocate science, and try to solve problems and not create problems.
Yeah, very profound there. Try to solve problems and not create problems. Thank you. So, Cuthbert, just a wrap up. Was you doing science passion or an option?
To be honest, in the beginning, it was more like an option. But I would say it became a passion over time, because I got to realize, firstly, second born. So going into university, there was this pressure of I need to go and do or study something like medicine, or being in the health profession, and that was the initial expectation. But then I chose something which I was very much informed about and aware of. And I said, okay, let me use this as an option in terms of me studying, getting a qualification, and getting a job. But then when I was, and I think in my second year before final year, I actually sat down and, realized that parents want to go and study medicine. I saw it because I knew already about microbiology. A classmate of mine, his dad was actually a university professor at Fort Hare, and to his father, his father was the only parent who was well educated and all of that. So we as kids, we used to look up to this man. He was a full professor, well established, doing well for himself and his family. And when I asked from my friend what his dad was doing, he told me, no, my dad is a microbiologist. He deals with viruses, he deals with bacteria and all those things. And he also makes perfumes. Once he mentioned those three things, I said, no, this is actually something I want to do. Because when I applied for university admission, microbiology was one of the applications, one of the areas I had applied for. So hence I'm saying in the beginning, if you look at it, it seemed like an option, but as time went, there was passion involved because I got to a point where I started to rediscover myself as well as the discipline which I was studying, and then that is where the passion came from. So to answer your question, it's a passion.
Yeah, I can tell it's passion. The way you've handled this interview, I can tell like it was just oozing out of you. The way you would do this in your sleep. So if somebody wants to get hold of you, maybe they want to ask you a nice question about microbiology, how can they get hold of you on social media?
Okay, so I'm available on Twitter. My Twitter handle is at Kibs28. Then I'm also available on Facebook, and I use the names Cuthbert Kibungu. And the same with Instagram, it's at Cuthbert Kibungu. And then, that's basically the platforms on social media which I'm available. I'm also available on LinkedIn, so they can search me as Cuthbert Kibungu once again, and they should be able to find me.
Okay, thank you so much, Cuthbert, for that informative session. And I hope that this seed that we just sowed will grow forever and ever. Thank you so much for joining me. And I'm your host, Bitimela Mamadi Mamarope, signing out. Bye.
All right, bye. Thanks for having me.
Okay, you're welcome. Thanks. Bye.